All right, find the limit of this. Again, whenever you're doing a limit, the first thing you want to do is try to plug in 0. So sine of 0 is 0, and e to the 0 is 1, so we get 0 over 0. And whenever you get 0 over 0 or infinity over infinity, you're going to use L'Hopital's rule. So the derivative of sine is cosine. The derivative of e to the x minus 1 is e to the x. And I try to plug in 0 again. Cosine of 0 is 1, e to 0 is 1, and I get 1. And so A should be the correct answer. All right, a particle moves along a straight line. Its acceleration is 12t. We know its kind of initial velocity and position. All right, what is the actual formula? So we know if we go from acceleration to velocity, we have to do an antiderivative. So we're going to go from 12t, and the velocity is going to be 6t squared. Right? Add 1 to that exponent, divide by 2. And then we have to take a antiderivative, you get a plus c. But they told us at the start, when I plug in 0, which would make this go away, the velocity should be 2. So it's actually telling me that the c should be 2. And then to get from our velocity to our position, we do another antiderivative. So it's going to be t cubed. 6 divided by 3 is 2, plus 2t plus c. And they tell us that our position at the start is 5, again, because if I plugged in 0, all this would go away. It's basically telling me that the c value is 5. So I'm just looking for the one that matches, and that looks like it is D. All right, so basically I'm just taking two antiderivatives and knowing this kind of middle sentence here tells me what those c values are as I go along. All right, let f be the function defined above. Which of the following statements must be true? So it's either continuous and differentiable or some combination of not being those things. So the first thing is continuous. When we switch at a piecewise function, in order to be continuous, we got to make sure there's not a jump. So we have to make sure these two pieces match up. So let's plug in 5 into both of these. All right, so I plug in 5 into the left one. Real important that that negative is in front of the x squared, so I square 5 first and then apply the negative. That's negative 23. Oh, sorry, not 23, 22. And if I plug in 5 into the bottom one, I'm also going to get negative 22. All right, so there's not that jump there, which means this function should be continuous at 5. All right, so this one and that one are out. And now we can figure out, is it differentiable? Well, differentiable means we kind of have the same thing. We don't have this jump, but that's related to the tangent lines instead. So now what we have to do is find f prime of x, which is going to be these derivatives of these things. There's going to be negative 2x, and this is going to be negative 10. And now we have to plug in 5 where that jump happens. So if I plug in 5 here, I'm going to get negative 10. Here, it doesn't matter what I plug in, I get negative 10. And again, those match up, so this function actually is continuous and differentiable at this point. All right, it's continuous because the original functions, if I plug in that place where I switch, I get the same value. And it's differentiable because the derivatives, those are the tangent lines, those also line up and they're exactly smooth and you get the same value on both sides. All right, if dy over dx equals 2 minus y, and if y equals 1 when x equals 1, then y equals what? All right, so there's a few different things you can kind of see. This is one of the questions related to that optional topic we did when we were doing substitution, which was differential equation. So when you have this derivative and a y in the same equation, it's a differential equation. So you could just skip this question when you see it because you didn't learn it. But there's some things you can know. So if x equals 1, y should equal 1. All right, well, I should just make sure that if I plug in x equals 1 into any of these, I'm going to get y equals 1 because that'll help eliminate some of my options. All right, so if I plug in, say, x equals 1 here, I do get 1. All right, the second one, it's pretty much the same thing. I get 1. I have at c and d, 2 minus e to the negative 1. That's not going to be 1. 2 plus e to the negative 1 is also not going to be 1. So automatically, just off of this statement, knowing nothing about differential equations, I can eliminate c and d. And that kind of narrows down my options. Now you have a 50-50 shot at getting it right. But how could you do it exactly? All right, there's a few different ways you could do it. exactly, but one way you could see is if this is my answer for y, and I can find dy dx. dy dx of this is going to be negative e to the x minus 1. All right, so I'm taking this, took the derivative of this like we always do. All right, the 2 goes away. Derivative e to the x minus 1 just gives me back the same thing. And if I plug this into this function, it's going to make sense. So the derivative is negative e to the x minus 1 equals 2 minus the y that we're picking. All right, the 2's are going to cancel, but I get negative e to the x minus 1 equals positive. So a is not going to work. And we did all the same thing with b instead. B, the derivative ended up being positive. And then you end up actually getting them equal. And so b ends up being the right answer. If I choose y equals this, I plug that exactly in there, I plug its derivative in there, that equation is true. So even though you don't really know all the ins and outs of differential equations, you can kind of use the answers and the information provided you to try to kind of narrow down your guesses as you go. All right, so g is going to be this function defined this way. What is the x-coordinate of the point of inflection? So the point of inflection is when our graph goes from concave up to concave down, or vice versa, concave down to concave up. And that has to do with the second derivative. So the first thing I'm going to do is find the second derivative of this function. Well, the first derivative, remember when you're taking the derivative of something with this integral sign, they kind of cancel out. So the first derivative of this is actually the first part of the fundamental theorem of calculus. The first derivative is x squared minus 5x minus 14. All right, just kind of plug that x there in for those t's. And now I can take the second derivative the way we always do, 2x minus 5. All right, and the point of inflection is where the second derivative goes from either positive to negative or vice versa. All right, how do you switch from a positive to a negative or a negative to a positive? You have to go through 0. So really we're just going to figure out when this equals 0. And that's the only option that's there. It's not guaranteed that just because it's 0, it's a point of inflection, because it could stay positive on both sides and it's always concave up. But in this question, there's only one possible point of inflection, and that's the answer. All right, so point of inflection where the second derivative is 0, or more importantly, changes sign, which means it crosses 0. All right, what's the derivative of this function? All right, the first thing to realize when you're taking this derivative is that it's x cubed times secant of 2x. Which means we have to do the product rule. So the product rule says I keep one of the functions, so I'm going to keep x cubed. And I multiply that by the derivative of the other function. So I'm taking the derivative of secant times 2x. It's technically a chain rule because there's a 2x inside the parentheses. But we take the derivative of secant first, which is just kind of one you have to have memorized, secant of 2x, tangent of 2x. And I have to multiply that by the derivative of the inside, which is just 2. Then I add the derivative of the first part, which is going to be 3x squared, times the original second part. And you can see there's two options that are really similar. All right, that's C and D, but D has that extra 2 at the front, so this answer should be